As we continue our work with terms, there's a very important concept to understand, the concept of what we call like terms. Like terms can either be constant terms, and what we mean by a constant term is simply a term that's strictly a number. So 4 and -8 are examples of constant terms. And we always consider constant terms to be like terms. If the term has a variable in it, we call it a variable term. And variable terms are like terms if they contain the same variable and those same variables share the same exponent. Let me give you an example of a pair of like terms. This is a pair of like terms. They are variable terms. They contain a variable. They're not constants. Constant terms don't have a variable. They're variable terms. They have the same variable, x, and those x's have the same exponent. Because remember, when no exponent is written, the understood exponent is 1. So there's a pair of terms that are considered to be like terms. The terms 5x squared and -9x squared would be considered to be like terms. They are variable terms. They have the same variable, x, and the same exponent in both terms, x to the second here, x to the second here. These terms would be considered to be like terms. They're variable terms that have the same variable. X is here in this term. This term contains y variable. This term contains y variable. And those common variables have the same exponent. It's the first power here for x, first power here for x, second power here for for y, second power here for y. So both conditions are met. Those terms would be considered to be like terms. Now, let me give you some examples of terms that would not be considered to be like terms, and see if you can pick out where it fails the definition. These terms would not be considered like terms. And I think you can see the reason they would not be considered like terms is because they don't have the same variable. This term has x, this term has y as its variable. Here's another example of a pair of terms that would not be considered like terms. They are unlike terms. They both have x, but x is to the second power here, x is only to the first power there. So yes, they have the same variable, but they don't have the same exponent. It's very important to understand this concept of like terms, because when we start operating on terms, and in particular when we start operating by adding and subtracting terms, which is also what we call combining terms, we can only combine terms if they are like terms. We can only add and subtract like terms. So it's very important to understand the concept and be able to recognize when you have terms that are like terms or when you have terms that are unlike terms.